सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video we have discussed about a lot of things regarding to just electrode potential. What is the meaning of electrode potential, types of the electrode potential as a just oxidation electrode potential and reduction electrode potential, and we also discuss about the just use of the electrode potential, because of it will be use of standard reduction electrode potential, not to be standard oxidation electrode potential, because of if we use just standard oxidation electrode potential, then the value of EMF will be just negative, and it is not possible the value of EMF of the cell or just standard value of the EMF of the cell will be just negative. So particular वहाँ EMF की वैल्यू पॉजिटिव करने के लिए हम E नॉट ऑफ रिडक्शन मीन्स रिडक्शन स्टैंडर्ड रिडक्शन इलेक्ट्रोपोटेंशियल का यूज करते हैं। उसके बाद में हमने बात की पर्टिकुलर कि रिडक्शन ये जो सेल का EMF है वो किन किन बातों पे डिपेंड करता है, उसके रिगार्डिंग वी हैव डिस्कस अबाउट द जस्ट नॉन इक्वेशन एंड द फोर इंपॉर्टेंट एप्लीकेशंस. What are they? Just we have discussed about the just how we can calculate the EMF of the galvanic cell. Second, how we can calculate the just electrode potential of a particular half cell. Third, we have discussed about the just equilibrium constant for a just cell. You can say just galvanic cell, and how we can calculate the just you can say your Gibbs free energy of a cell. How we can calculate. This was about the just applications of the galvanic just Nernst equation. Now the time to discuss about the just uses of electrode potential, or just you can say what is the meaning of electrochemical series. It's a very important topic and it will be just a lot of question. So if we'll go with the just uses of electrode potential, then it will be taken in the form of electrochemical series. So this is the electrochemical series, and its application and its applications. If you will go with the just electrochemical series, then if we'll arrange, if there is arrangement of standard reduction potential of different elements in ascending or descending order, then forming series is called as just your electrochemical series. So what we can say that this kind of a series gives us the information about the standard reduction electrode potential. This is given standard reduction potential or standard reduction electrode potential. This here you can use just electrode potential also. Electrode potential. For example, just there is you can say Cu plus 2 oblique Cu changes, then its value is your plus 0.34 volt, and if there is suppose Zn plus 2 oblique Zn, then its value is your minus 0.76 volt. So these are the just part of the electrochemical series. If we'll go with the just applications, then here's the applications of just your electrochemical series. So here is the first application. To know to know oxidizing and reducing character. Reducing characters. Suppose you are given just two elements, and if there is a question which of the element acts as an oxidizing agent and which of the just reducing agent, then remember one thing, just elements having less value of E naught of reduction, or just you can say negative value, they undergo oxidation and acts as reducing agent, reducing agent, or just you can say reductant, while elements or metals having more value or just positive value of E naught of reduction, they undergo just reduction and acts as oxidizing agent. This is the most important part. Suppose if there is a given E naught of Zn plus 2 oblique Zn, we have discussed its value is minus 0.76 volt, and E naught of Cu plus 2 oblique Cu, it's your plus 0.34 volt. If you go with these two data, then you can see here's the value is negative, means less than this value. So if we'll go with the just negative value, it undergo oxidation. So undergo oxidation and acts as reducing agent, or you can say reductant. While if we'll go with this, then it undergo reduction reaction and acts as oxidizing agent, or just you can say oxidant. So this was about the first application. If we go another question, then this is the F2 just changes in F minus. This is the most important. F2 is the fluorine, and if you go with this value, then that is your 2.87 volt. The value will be just your, you can say positive. And if I'll go with the just Li plus changes in Li, then the value for the lithium is your very important, that is your minus 3.05 volt. So which acts as a just oxidizing agent or which acts as a reducing agent, this just depends on you. If we'll go with this, then its reduction will be fast because its value is your positive. So it acts as an oxidizing agent, great oxidizing agent in entire electrochemical series because it's a highest value. And if you will go with this value, then it acts as a strong reducing agent. Yeah, strongest reducing agent. This was about the just first application regarding to your electrochemical series. Take this just topic or just this slide very seriously because of it will be a lot of question in board examination also. If we'll go with the next application, then we can take second application as a uses of electrode potential, or you can say electrochemical series. That is the to know about second application is your to know about feasibility of a redox reaction. किसी भी redox reaction की feasibility को find out करना. For example, if we'll go with the just reaction of the galvanic cell, that is your Zn plus Cu plus 2 changes in Zn plus 2 plus Cu. We have to check this reaction is feasible or not according to the equation. So listen me carefully. Reactions having positive difference of electrode potential, then redox reaction will feasible according to equation in forward direction. But for negative value direction of reaction will inverse. If we go with this reaction, then we can take the important example. So here is just E naught of cell. For this, Zn is given E naught of Zn plus 2 oblique Zn. This is given minus 0.76 volt, and E naught of Cu plus 2 oblique Cu, that is your plus 0.34 volt. And we all know E naught of cell is equals to E naught of cathode minus E naught of anode. As a cathode, here is the use of copper electrode, so its value is your plus 0.34, this is the minus, and Zn electrode acts as an anode, so this value is your minus 0.76, so this will be your plus 0.34 plus 0.76, so the value will be 1.10 volt, as a just difference is positive. So you can say this reaction is possible in the forward direction. This was about the second application. We will take another example also, go through with the matter. It's too important. Now I would like to go with the another example regarding to the second application. We have to know about the feasibility of the another reaction, that is feasible or not. If you will go with this kind of the reaction, then this is possible in forward direction, not in backward direction, because of value of E naught is positive. The another example we can take, this is the 2 of Ag plus Cd plus 2 changes in 2 of Ag plus, and this is the Cd. If we'll go with the value E naught of Ag plus changes in Ag, another is your E naught of Cd plus 2 changes in Cd. The value for the Ag, just Ag means silver, that is very important. And what is that? The value is your 0.80. 0.80 volt. This is the 0.80 volt. And if we'll go with the just CD cadmium, then the value of the cadmium is your minus 0.40 volt. The value is your E naught of cell is equals to E naught of cathode minus E naught of anode. If you will go, then Ag changes in Ag plus, it acts as a just anode, and Cd plus 2 changes in Cd, it acts as a cathode, because here's the reduction. So as a cathode, it will be use of cadmium. The value is your minus 0.40, and this is the minus. Its value is your 0.80 volt. So this is your minus 0.40, and this is your minus 0.80. Value remains minus. It will be your 1.20 volt. So what we can say that difference is negative. So reaction is not possible in forward direction according to the equation, but it is possible in backward direction. Like this, you can say 2 of Ag plus, this is the Cd, this is the 2 of Ag, and this is your Cd plus 2. Now the value will be positive. How? You can see. Now this is the anode, this is the cathode, and this is the anode. So you can see E naught of cell is equals to E naught of cathode minus E naught of anode. As a cathode, here will use of just Ag. So the value of Ag is your given, that is your 0.80. This is the minus. For the anode, its value is your minus 0.40. This remains 0.80 plus 0.40, value will be 1.20 volt. So what we can say that the difference is positive, so reaction will be according to this equation in forward direction, not to be according to this equation. This was about the second application regarding to the that's your electrochemical series, or you can say electrode potential. Now the time to discuss about the third important application. What is that? That is very important also. To know, third application, to know about displacement of S2 on reaction with acid to a metal. यानी कि कोई भी मेटल एसिड के साथ रिएक्शन करेगी तो नो डाउट H2 गैस देगी. किस प्रकार से देगी, कौन सी गैसेस देंगी? सो रिमेंबर वन थिंग, metals having less value of E naught of reduction, less value, that may as a positive or maybe as a less value, metals having less value of E naught of reduction than hydrogen can displace just H2 gas on reaction with acid. उस पोजीशन में हम बात करें तो इसका मीनिंग ये है कि एक ऐसी मेटल जिसके ई नॉट की वैल्यू, ई नॉट ऑफ रिडक्शन की वैल्यू हाइड्रोजन से कम हो, हाइड्रोजन के लिए पर्टिकुलर वैल्यू क्या होगी? दिस इज द ई नॉट ऑफ H प्लस ऑब्लिक H2 एंड द वैल्यू इज योर 0.00 वोल्ट, और इससे लेस वैल्यू नेगेटिव वैल्यू होगी। मीन्स जिन मेटल्स की ई नॉट ऑफ रिडक्शन की वैल्यू नेगेटिव होगी, केवल वही पर्टिकुलर एसिड के साथ रिएक्शन करके H2 गैस डिस्प्लेस करेगी। दैट्स व्हाई Ag, Au और Pt कभी भी एसिड के साथ रिएक्शन करके H2 गैस डिस्प्लेस नहीं करती। बट इफ विल गो विद द टू मेटल्स, एग्जांपल, दिस इज द वन ऑफ द Zn plus H2SO4 gives you ZnSO4, release of H2 gas, and another reaction is your Cu plus H2SO4. This is the CuSO4 plus H2. If we'll go with the just value of reduction potential, then E naught of Zn plus 2 oblique Zn changes in, then it gives minus 0.76 volt, and E naught of Cu plus 2 oblique Cu is your plus 0.34 volt. So what we can say that Zn exists less value of the E naught of reduction than the hydrogen, so it can displace H2 gas on reaction with acid, while copper exists positive value than more value than the hydrogen, more value, that is for the hydrogen is your 0.00 volt, and it is high, so it cannot. So that's why we can say first reaction is possible and this is not possible. This was about the third application as a just to know about the displacement of H2 on reaction with acid to a metal. Now I would like to go with the fourth application, that is in the displacement of metal from the solution. This is the fourth application to know about displacement of metal from their solution. Remember one thing, metals having less value of E naught of reduction can displace metals from their solution having more value of E naught of reduction. मेरा मीनिंग क्या है कि जिनकी पर्टिकुलर E naught ऑफ रिडक्शन की वैल्यू लोअर होगी, वो हायर वाले को उसके सॉल्यूशन से डिस्प्लेस कर देगी. For example, if we'll go with the example, then there are two examples. First is your Zn plus CuSO4 gives you ZnSO4 plus Cu, while another reaction is your Cu plus ZnSO4. This is the CuSO4 plus Zn. These are the two reactions. It's very important. We all know E naught of Zn plus 2 oblique Zn is your 0. minus 0.76 volt, while for Cu, E naught of Cu plus 2 oblique Cu is your plus 0.34 volt. This is the less value, this is the more value. So this metal can displace to the Cu from its solution. So first reaction is possible, while second reaction is not possible. So what we can say that means we can say that CuSO4 cannot keep in containers of just Zn, while ZnSO4 can keep in containers of just you can say Cu. This was about the fourth important application as a to know the about the displacement of the metals from their salt or just solution. It's a very important part regarding to the electrochemistry. It will be one of the question what will be when we'll suspend the zinc rod in the CuSO4 solution, then you will say it will be disappearing of blue solution of the CuSO4 because of Zn reduces to the Cu plus 2 in Cu. So, dear doctors and engineers and chemistry lovers, this was about the applications of the electrode potential regarding to just you can say electrochemical series, and it will be a lot of questions as a just conceptual question regarding to your electrochemical series and applications of the E naught of reduction. We'll meet in the next video with a new topic, with a just a new atmosphere, with a new matter, with a just next वीडियो. टिल देन शुक्रिया, धन्यवाद. यही अपना विश्वास ट्रस्ट जताते रहिए और मेरे साथ कदम से कदम मिलाकर चलते रहिए. सो धन्यवाद, शुक्रिया.